Okay, time's up. The reporter will present your report for the next 12 minutes. Let's start now.
Dear Honorable Judges, today my topic is rice vegetables, and my name is Li Xinzhen. My team is called We Are Family, and I'm from Kaohsiung Municipal Kaohsiung Girls Senior High School. So the important statement is to take a vessel and pour some granule material into it, for example rice. If you dig e.g. a spoon into it, then at a certain depth of immersion, you can lift the vessel and contents by holding the spoon. Explain the phenomenon and explore the relevant parameters of the system. For outline, the first thing I'll talk about is introduction, and then theory and analysis. And then we're going to talk about our experiment, discussion, and conclusion. For theory, the first one I want to talk about is what is a granule material. Granule materials are composed of tiny particles that barely interact through contact forces. Usually don't stick together unless they are moist, like sandcastles, or they are very small and subject to attractive molecular forces. So when particles are in a specific shape, such as long, thin rods and U-shaped staples, they can form tall and rigid pells that hold their shape like a solid. These pells resist being pulled apart due to the cohesive nature of their geometry, which is referred to as geometric cohesion. And so after reading this reference, I think that this situation is kind of like rice vegetables, which is when you put the stick into the beans, it is hard to, the beans will resist being pulled apart. Okay. So for theory, the first one is the formula. F equals mg and equals fs. And the second point I want to talk about is the pressure of the weight of the grains. So the weight of the grains on top presses down on the grains below, creating a pressure that increases towards the bottom of the pellet. And this pressure can cause the grains to lock together and form a stable arch-shaped structure. And then it's about our experiment. So as the spoon lifts, the grains around it becomes slightly less compressed, which can cause arch structure to break down. However, if we lift the spoon too far or too quickly, the structure can collapse entirely, causing the rice to flow out of the vessel. So the key is to lift the spoon slowly and carefully so that the structure remains intact. And for several factors are size and shape of the grain, and size and shapes of the vessel, and the filling rate of the material. So for our experiment 1, we compare the maximum stress among various types of beans these beans could afford. There are green beans, so we found that the moxo millet can afford the highest maximum stress, and then is the orzo sective indica, and then it's the stick rice and green beans and red beans. And further experiments, we choose green beans for our experimental group because we can maintain the velocity of pulling the stick inside the beans. So it will, just like at the previous stage, it will not break down the bean easily. So for our experiment, we compare how different parameters affect the maximum friction. For control variables, we use green beans and the same tube and wooden stick. We choose to use wooden stick instead of wooden spoon is because the wooden spoon has a different structures for the whole part, while the stick is more stable. And for independent variable, our experiment 2, our third independent variable is the radius of the stick, and experiment 3 is the radius of the tube. And then for experiment 4 is the depth of the stick, and for experiment 5 is the thickness of the outer space. So for the first one, the radius of the stick. We found that the longer radius of the stick, the higher maximum static friction it can afford. So this is the graph. And for the next graph is about the radius of the tube. So we can see that in a specific range of the radius of the tube, the longer radius of the tube, the smaller maximum static friction it can afford, which is the range of 2.8 centimeters to 5.6 centimeters. However, there is a turning point between 5.6 centimeters and 7.22 centimeters. And we found out that maximum static friction comparing the radius of the tube would remain when it's longer than 7.22 centimeters. Next is the depth of the stick. As you can see, the longer depth of the stick, the higher maximum static friction it can afford. And I think it's resolved by the surface, the attached surface, the green beam, and the stick, which means the larger surface at contact, the higher maximum friction it will create. And then we used a stent paper to surround the tube and to see whether it will also affect the maximum friction too. So here we see that the higher thickness of the outer surface, the higher maximum static friction it can afford. So for ATCW is the roughest surface of the tube, and as for 240 CW, it creates the last rough surface. And then I want to discuss how strain size affects maximum friction. So first, I use jet bank, green bean, rice, and millet to compare. As you can see, millet is the highest, and then it's rice, and green beans, and red beans. However, these beans have different surface properties. So I want to know more accurate data of this question. I used longer glutinous rice and round glutinous rice. So for information, round glutinous rice is smaller than long glutinous rice. And we also found out that the smaller the beans are, the larger maximum friction it will afford, which is actually the same as the first graph. And then we want to discuss how the different friction strengths affects the maximum friction. So first, we calculate the coefficient of static friction. First is the purple rice, which is 6.268, and long rice is 6.287, and then long brown rice, which is 6.325, and then long glutinous rice. So to measure this coefficient static friction, we use state and see which degree it will fall and to calculate it. So in this graph, we see that the higher coefficient of static friction, the higher maximum static friction it can afford. Okay. After knowing this, I would want to know how different friction of the tube will affect the maximum friction. So we know that the rougher the tube, the higher maximum friction green beans can afford, which is same as the previous pages. For conclusion, is to measure the parameters that will affect maximum static friction. The first parameter is the radius of the stick. So we found that the longer the radius of the stick will afford will afford a higher maximum friction it can afford, and for depth, and this also result in the depth of the stick. And for the roughness of the outer surface, the higher roughness of the outer surface will create a larger maximum static friction. The most interesting part I found in this experiment is the least point, which is in the specific range of the radius of the tube. The longer radius of the tube, the smaller maximum static friction because the fork. However, there is a turning point between 5.6 centimeters and 7.2 centimeters. So I'm actually really interested about how this phenomenon occurs. And for discussion, I want to talk about how the stick attach the green beans. So for my data, I can calculate the whole surface that attach the green beans. However, we cannot observe the specific area of each stick when it contacts with the green beans. So we are still investigating how to observe the specific area of static instead of the whole stick. So thank you for your attention.
All right. Can you present? Okay, thank you. All right, so next 2 minutes, your opponent will ask questions. Okay, for 2 minutes.
Which force do you think that affect the experiment the most? So gravity, normal force, or friction?
Can you say that again?
When you are calculating the friction, do you only calculate the friction between the particles and the spoon?
Yes.
Okay. And will the depth affect the friction?
Yes.
Okay. And when you're doing the experiment, will the acceleration affect the experiment?
Acceleration.
Acceleration.
You mean with a stick?
How fast you pull the system?
Actually, we remain our force, so the speed is.
And is your lifting force in your every experiment is the same?
No, because.
Okay, thank you. And how about the mass of the system in your experiment? It is all the same?
The mass of the system, yeah, it's the
Oh,
same.
it's the same. Okay, so the shape of the particle will affect the experiment. Yes or no?
Yeah.
So, do you consider the friction between the particles and the container?
Yes, because I use a standard.
And how about the friction between the particles and the particles?
We did the previous page.
Okay, thank you. So, does the arrangement of the particles affect the experiment?
The arrangement of the
Yes.
particles.
Arrangement. Let's say how. Never mind.
Yeah. Yes, it did. It did.
And is the contact area between the maybe the spoon and the particles the same?
No.
No. So different particles will have different contact area, right?
Right.
Okay. So which one is easier to make a phenomenon happen? The rod or spoon?
The what?
Which one is more
Hands
easier?
up, thank you. All right, opponent will prepare for next 3 minutes. 3 minutes up, opponent will take the floor. Next
Hello?
2 minutes. All right, stop.
Hello, honorable jurists and all the fellow competitors. I'm the opponent from Team South here. Today, I'm going to oppose problem number 12, rice kettle gills. And here's the problem statement. Take a vessel and pour some granular material into it. For example, rice. If you dip, for example, a spoon into it, then at a certain depth of immersion, you can lift the vessel and contents by holding the spoon. Explain this phenomenon and explore the relevant parameters of the system. And I'm going to then focus on what caused the system to achieve the condition of static balance and how to calculate the certain depth at which the phenomenon happened, and also what factor caused the deviation. And here are the strong and weak points of the reporter. First, he has a clear qualitative explanation about the friction and the pressure that acting on the system, and she also considered the friction between the particles with the metal. I think that plays an important role in the experiment. But she didn't have a qualitative explanation. And I think her experiment is not the data of her experiment is not enough. But she also did a great work on changing various kinds of particles in the system and control the total mass of the system. And here are some points I would like to discuss in a further discussion. First, I want to talk about the Jensen effect that explain the relation between the depth and the pressure. And also, because we have the pressure and you will cause the friction, that the reporter thinks that is the most important force that make the phenomenon happen. And also, I'll talk about when she lifts the system, and it's a static balance, so that the lifting force and also the kinetic area will be the same. Lifting force will offset the kinetic area. And also, just like the problem statement has mentioned, the certain depth, like the boundary condition that can make the phenomenon happen. In the experiment part, I would like to discuss about different parameters that it might influence the experiment. First, I would like to talk about the friction coefficient, the rod, the friction coefficient of the rod, the spoon, the particles, and also the vessel, and also some properties of a particle like the density of it, the shear of it, and also the friction coefficient and how and I'll talk about how she measures the friction coefficient. And next is about the kinetic area, because we need to know the friction acting on the system. So first we need to know the kinetic area acting between the particles and the rod. And I would like to know how she measures about it. And also about the acceleration of the system that the reporter had mentioned about that it might affect the experiment. And also I talk about how she measures the boundary condition, that's the critical value of depth that can make the phenomenon happen. And in the deviation part, I'll talk about the static and kinetic friction acting between the particles and the rod or the spoon. And also, I would like to know how the arrangement of the particles will affect the experiment. Since we know that in her experiment, she has many different kind of particles like green beans, red beans, and also rice. And I would like to know how it will affect, because their shape is different. And last, I'll talk about the acceleration of the system, because she said that a lifting force in her experiment is all the same. So I would like to know how the acceleration of the system will affect the whole experiment. Thank you.
All right, next 10 minutes, we'll have a discussion between the opponent, reporter and opponent.
May I use the blackboard?
Sure.
We have mentioned about that the friction can affect the experiment the most, right? So if this is a vessel, and this is a rod, and this is a particles, can you explain, can you show me where the friction acts? Can you show me the friction, direction of the friction acts in this system?
Direction.
Yes.
Here.
And the direction. So this is the direction between the rod and the particles.
Yeah, and also this one is to affect how our force.
You mean?
However, the attachment of the remain is actually here.
I mean the pressure.
Yeah.
Okay, and how you have and here I agree with a reporter like this direction is the friction that the particle give to rock. And how about the friction between the particles and the vessel? Yes, you say you did consider about it. Can you show me? Also, the friction here is the same direction as here. And how will this affect in the experience?
So if the friction here is larger, it can make the larger maximum friction here.
Also, you mean that if the friction coefficient of the vessel increase, you make more easy to let a phenomenon happen?
No, it's the higher coefficient of the tube. The higher maximum friction is to this thing.
Okay, so you mean that the friction is bigger, it's more easier to lift the system up, right? You mean that?
It's harder.
It's harder. And so, which one do you think is more important, the friction here or the friction here?
I think both is important because as you can see here, it will affect our result. However, state is the main thing that.
And here I disagree with the reporter because I think if we lift the system up, like if this is the particles, now you have the gravity down here, right? And also you said that this is the direction of it, but the opponent think that the direction that the vessel, the direction of friction that the vessel gives to the particles is upwards. And also, I think the friction between the particles and the rocks, this is the direction that the particle gives to the rock, and but the friction that the rock gives to the particle, I think is upward. So I think this will balance. So when you are calculating this, I think that these three forces will balance. So when you are calculating.
Force, like here or this?
I mean here. This is the direction that I think is a direction of friction that the vessel gives to the particles, and I think that because I think this will equal to the gravity. So I think when you calculate this, you also calculate this. You agree?
No, because when we are holding the stick, you have an F here. And well, this one is F1, F2, and F2. However, I think it's like this.
Oh, okay, I know. And about that question, because you said that the friction is the most important, right? So we can know that the friction will equal to the mu multiplied the pressure and the area. Can you explain how you measure the kinetic area between the particles and the rock?
Well, because we know that it comes as F, right?
You mean? I mean, how do you calculate the kinetic area between the particles and the rock?
We use the maximum friction and to minus here and here, and to divide the coefficient.
Oh, I know. So you assume that if this is you assume that the surface area of here, the rock, is a kinetic area. And the opponent think that maybe the reporter can, because we know that if this is a rod and this is the particles, the kinetic area is only at here and here and here. So I think that maybe the reporter can have a fitting constant to know the actual kinetic area about here.
Wait, but
Next question. Please turn to page 7. The next page. So, can you tell me maybe that different particles, the return of different particles? You said you control the total mass of the system, right?
Yes.
But you have the different particles. How can you control the mass of it?
I use the same as the mass.
Oh, you mean that even the amount of the particle is different, the mass is still the same?
No, because here we push the stick in the same depth. And so for the whole mass of the system, we can just first measure the system and to compare it. So no matter how many grams is contained, it won't affect.
Okay, thank you. And I want to know, because you did the experiment about different particles, right? So I want to know how the shape of the particles will affect the experiment.
You mean shape? So
Yes.
the smaller shape, the higher maximum static friction.
Can you tell me why?
Because, as you said here, like, so here, this is a larger size of this ring. Here is a smaller one. So it may didn't attach to the system, but there's less attachment that it didn't.
Oh, you mean that the kinetic area will be bigger?
Yes.
Oh yeah, and here the opponent agree with the reporter that because it can have more kinetic area, it can more easy to let the phenomenon happen. So, but I want to know that when you are doing when you are doing an experiment, when you are calculating a theory, do you assume that the friction between the particles and the rod is a static friction, right?
Yes.
But when you lift the rod, right? When you lift the rod like this, the particles here will rotate.
Right.
It will rotate.
Yes.
So it will turn into kinetic friction.
Right. But here we measure the maximum friction. So the turning point is actually related to the static friction, coefficient.
But you said that you have acceleration in your experiment, right? When you follow the system.
Right.
But if it have the acceleration, how can you make sure that the friction between the particles and the rod is a static friction?
When the we do our best to maintain the velocity, we pull it off. So the acceleration is, we can minimize acceleration, and moreover, no matter how.
Oh, you mean try to reduce the deviation caused by it, right?
Yes, but the acceleration, no matter how the acceleration is, the main point is we measure the velocity.
Please turn. Okay, thank you. Please turn to page 8. Can you explain me why the error bar here is bigger than the others?
This is like
Deviation.
yeah, deviation.
And what do you think that what will cause the deviation?
Because here 2.8 centimeters is like, you can see here and here there's smaller deviation. However, here
Yes,
it's harder to maintain the velocity
also.
in this because it's too.
So you use your hands to lift the system.
Yes,
And how can you control the lifting force?
we have instruments to measure the force.
So
Time's up, thank you.
Thank you.
Thank you. Okay, the opponent will summarize the discussion for 1 minute.
And in the discussion part, we have discussed about the friction between the particles and the rod. And we found that the direction of the friction acts opposite to the gravity and acting between the particle and stick. And so that make the system able to lift that the friction is offset with the gravity. And also measurement of the kinetic area between the particles and the rod, because we need to know the friction. So of course we need to know the kinetic about here. But I think the reporter can calculate it more well. And also about total mass of system, I think in the discussion we have talked about reports that the mass of the system is the same. I think that and the reporter did a good job here. And also talk about how the report controller forced to insert into the particle and how she lift the rod. And I think that when she lift the rod, I think with doing experiment with hand, I think it will cause a lot of deviation. And also I suggest that we should...
Hands up, thank you.
Okay, thank you.
Okay, the reviewer will ask a question for the next 3 minutes. Please, before. The test is running now. You can start.
What's different because of statement?
Oh, so like the spoon, the size of its down part is actually very different from the upper part. So we choose to use stick instead of the spoon.
Can you tell me what's the difference of the shape between the frames you have?
The different shapes. There is long or round. Like there's three main wrappings, knotted rice and long rice. So for long rice, the shape is actually longer and tinier, and for beans, it is like rounder, like more like a circle.
What different shape will affect?
Different shapes. So for the round one, it can attach the stick more, and so the higher maximum friction it can afford. And so if the bean is like more longer, it will cause lesser maximum friction.
Can you tell me how is your first set?
Nice setup. Okay, so the tube and some beans and put a stick in it. And so to test the maximum friction, we actually need another force to add on it and then pull it up so we can test the maximum friction.
Can you tell me shape and size which causes more difference in the results?
I think it's the size, because during the previous pages, here, red beans, green beans, rice, and millet are all formed in different sizes. However, in different shapes. However, the smaller size of it, the higher friction in the burst. So I think it's mainly cause of the size.
Hands up, thank you. Okay, review will have 2 minutes to prepare for the next. 2 minutes. Okay, review, take the floor for the next 4 minutes.
My name is Wang Jing. I'm Tim from the group. I'm the reviewer. The purpose thing. We'll take a vessel and pour some metal material into it. For example, rice. If you did just bone into it, then at a certain depth of immersion, you can lift the vessel and contents by holding a spoon. Explain this phenomenon as well as relevant parameters of the system. That is in this question, the task is construct a reliable experimental setup with the producible results. 2. Qualitatively and quantitatively explain the phenomenon. 3. Investigation of effects of the important parameters and experimentally verify how they affect on the phenomenon. Now I'm summarizing of the reporter's presentation. First, understanding of the understanding of the problem. Part 2, their extension is problem. And their third analysis, F equals mg, mg equals Fs. The weight of the grains on the top presses the flux. Lift the spoon slowly and gently to make sure it doesn't affect the structure. If we lift fast, structure will collapse entirely. In their experiment, the radius of stick. Longer radius of stick will have higher maximum static friction. In a specific range of radius of the tube, longer is equal to smaller maximum static. We'll talk about the pros and cons of reporting. First, of the pros, they have a detailed explanation of the theory and a thorough explanation of the phenomenon. Experiment, they offers plenty of options of the grains. Third, in structure, they give clear definitions of granular materials. And for the cons, they lack in consideration of the shape and the differences between different grains. And for the experiment, they are lack of experiment photos. And in experimental improvements, their velocity of lifting is important. For the pros of opponent, they give clearly thoughts and truths and questions, and they extend discussions of the parameters. They consider a lot of force that might influence the results. For the cons, they have a little bit rushed, so they should pick a more important question to discuss deeper. The point raised by the opponents show the direction of the friction between particles and the sticks, and particles and the vessels.
Thank you. Okay, the reporter will have 2 minutes to make your final conclusion. 2 minutes.
So, as the reviewer previously, you said that I didn't consider the shape and the size. However, I did consider the different shapes. For here, I consider the shape and to measure the friction. And however, there's a huge surface property, so I decided to use this to compare different sizes to see how it will affect the friction. And you also said that I lack of experiment photos, and that is actually my problem because it is, I can it right now. Like it is mainly a tube and beans in it, and then I will push the stick into it in a certain depth, and then pull it off with a maintain velocity. So you talked about I didn't measure the velocity. Well, it is actually true, but I think that the velocity, that's how I pull, is need to remain slower, and we have to reduce the acceleration so that it will not, so that the deviation will be minimized. And I think that's all. Thank you.
All right, thank you. So, next 5 minutes, we will have the jury to ask the questions. Any question from the jury?
Yes,
Professor Lee.
I'm impressed by the one key word from the opponent about the critical depths you mentioned.
Yes.
Although you didn't mention your measurements, but you did mention that parameter, the critical depths. But did you guys do anything about the critical depths of the stick?
Yes.
You did. I probably missed the data you used.
I didn't show it up because we think that the depth, we did, but here, the depth of the stick. So,
How about the critical one? We all know that, if the depth is not longer enough, then you cannot get it up, right?
yes,
That's
like,
what I think the critical mean. So
you mean that when it,
I'm expecting to see a kind of theoretical model explanation to explain the value of the critical depths for your study.
oh, so when it's 5 centimeters, we couldn't
Okay,
even
so
pull it up.
do you have any explanation for that 10 centimeter?
Yes, because we think that the larger surface it attached, it will cause a higher friction it reproduce. So we need to have longer depth of the stick to resolve the
So
question.
also maybe opponent can say something more, and more comments about that issue?
I think that the certain that is in that how deep that you put the rod under in the particles, and I think that if she was going to measure the certain depth to let the phenomenon happen, I think she has still some parameters like she to control, or she can consider more.
Or any comments from the
reviewer?
Okay, thank you.
Okay. Any questions from professors? Professor Shea?
So can you show us your setup, experimental setup?
Do you have any experimental setup? You?
Can I draw it or?
You don't have it on the PPT,
I
right? So
do.
can she draw on the
So
board?
Okay.
the two, and then the base, and then we put the stick in here. And this is our current setup, and we pull up here, and we actually add another force here, so we can know how the F is start, the maximum friction is by adding this force. This applies only the
So
maximum.
how do you measure the friction?
We use instrument here,
What instrument?
the weighting system.
Scale?
Yeah, the scale. Like when, like a screw of.
Is it a screen scale or something?
Yes, it's, it can measure the force when you pull up in different directions.
So
Like,
that is a force, right?
Yes.
So how do you know it's something like that? So how do you recognize it as a frictional force? It
so,
is just a force, right?
Yes, but if this stick did pull up, the instant force its impact will be the friction, the maximum static friction, right?
Thank you.
Any question? Okay, I have no question for both of you, so we're gonna have a few minutes to make our grades. So please sit down. First, we're gonna have the grade for the reporter. 6, 5, 4, 5, 6. All right, and next we will have a grade for the opponent. 6, 6, 5, 8, 7. 6, 6, 5, 8, 7. 6, 5, 8. Let's see. 8, 7. All right. And next, we will have the grade for the reviewer. 5, 4, 4, 5, 5. All right, thank you very much. This is our first session, first stage. Okay.
Of the fluid traveling through. And it will cause, and this is how we calculate the straight hole number. And it causes oscillating and generate a specific frequency. And after we input the number of wind speed, we found out that the current vortex happens about 700 to 900 hertz inside our experiment, which we've also found out that this trend does not fit with other trends slope well. So the intensity here is actually increasing but not declining. And we believe that it's because of the Kármán vortex stream. And when we're assuming in our theory, we assume that radius of the hole and the nozzle is the same, and the hole passes through the nozzle straightly. And since through this equation, we can know the location of P and Q, the location here. And we can get the interaction area with the distance between the holes. And it is related to this relative intensity, so that we are able to predict that the relative intensity has proportional to this part. So after we modify the theory by dropping one of the square of n back into n powered by 1, we can get the trend of the relative intensity inside our experiment. However, there's still deviation inside this part, and we believe that it's because of turbulence that we cannot predict, and also the assumption of the theory that we are assuming that the airflow coming from the nozzle is traveling straightly through the hole. And since the assumption might be not that accurate, it might cause energy dissipation that we cannot predict to, and this is what we believe causes the deviation. In conclusion, in the first experiment that we conducted, we change the angular velocity or the revolutions per second of the rotating disk. When we increase the rotating disk, the speed of the rotating disk, it causes the airflow to be interrupted more frequently, which causes the frequency of the sound that we hear to increase. Well, in the second experiment, we changed the K, which is the number of the holes. We increased by 4 holes, 6 holes, and 8 holes, and 12 holes. We found out that the airflow will be alternately interrupted and pass through the hole frequently. It is because when changing the number of the holes, it also causes the airflow to be interrupted more frequently, which causes this frequency here to increase. And inside our experiment, you can find that the 8 holes, the first harmonic of the 8 holes is overlaying with the second harmonics of the 4 holes. And it is because that we're multiplying by 2 times. So from our equation, you can know that if the number is 2, we're seeking for the second harmonic, and while we're having 4 holes for the number of k, it will equals to the 8 holes with the first harmonic. And for our last experiment about the wind speed, we found out that the energy of the wind will increase because that the intensity of the sound is proportional to the cube of wind speed. And while the wind speed increases, we found out that the deviation also increases. We believe that is because when we increase the wind speed, it causes the Reynolds number to increase, which might fluctuate the fluid inside fluctuate the airflow, and causes more deviation. And in conclusion, we also found out that there are some specific peaks that are unexpected. For example, the peaks from 7 to 900 Hz. We believe it's because of the vortex shedding as an oscillating field at certain velocities and Reynolds number. And it causes the oscillating and generate a specific frequency and causes this part's intensity to, the trend of intensity to be unexpected. And for your relative intensity part, we modified our theory by dropping the square root of n back to n powered by 1. And we can get the trend of the relative intensity. However, there's still deviation in this part, which we believe is because of the turbulence flow inside that we cannot predict. And also the assumption of theory that the airflow is completely traveling through the holes on the disk, which might cause energy dissipation in this part. And this is the end of my presentation. Thank you.
Okay, thank you. Thumbs up. Okay, Poland will ask 2 minutes, okay, to the reporter.
Okay, thank you for the reporter's reporting. So I would like to know how does the distance between air gun and its effect will affect the airflow.
We believe that it will cause the wind speed that we're measuring to decrease if the distance between the air blower gun is increasing.
Okay. Also, did you consider the resistance or other disruption?
Please turn to page 7. So since we try to reduce most of the noises caused by the wind hitting on the metal perforated disc without rotating, so we try to avoid the deviation here.
Okay. Also, can you try to present more details about the pressure
I mean the pressure of the wind speed.
region?
When the wind speed increases, it causes the intensity to increases, and well, the wind speed is related to the air pressure.
Okay.
You mean the region of the sound?
Yes.
So it's a longitudinal wave when sound wave travels. Well, the reason why there is high and low pressure is because that when the airflow flows through the hole, it travels on an obstacle. So which means that it is the lower pressure part. But however, when the airflow hits on the metal disc, it is interrupted and causes a higher pressure part of the sound.
Okay. How about your experimental setup? Because you.
So I use an air compressor to provide the airflow, and I connected it with the air blower gun to exhale the wind out directly on this metal perforated disc. And in order to reduce some of the unexpected noises, we use a brushless mortar and a metal perforated disc. And the microphone we're
Thank
using.
you, time's up. Okay, opponent has 3 minutes to prepare for the next.
Okay.
Okay, opponent take the floor, maximum 4 minutes.
Okay, so what we talked about, we mainly focus on the frequency of the frequency of the flow, because for the reporter they talked about for the problem, and this is the problem statement, and I won't repeat it again. And for the poets, for the reporter they talk about the velocity of the airflow and angular velocity of disks. And also they consider the size of holes and the numbers of holes. And also for pros and cons of reporter, for the pros, they have broad explanation of the theory, and also they clearly quantify the formula which is related to the experiment. And also they consider a lot of different variables of the experiment. But for cons, I think they didn't consider the size of the holes and how the holes and the settle on the things affect the phenomenon. Because like what they mentioned in the report, that they mainly talk about the frequency of the flow, because they try the numbers of the holes and also the speed of the rotation of the disk. So that both influence the frequency of the flow. So I think maybe for the holes, for the size of the hole and how the holes settle on the disk is also what they can discuss about. And for discussions, so just like what I have mentioned in the previous page for the discussion, I think does the shapes of the holes, how does the shape influence the experiment? Because for this experiment, like for the reporter, they use the circle shape to do the experiment. But what will the shape affect the flow or even the frequency of the experiment? And also the second one is the airflow passing evenly through the disc no matter what the shape of hole is? And also because for their experiment, like for their flow, I don't think there are almost many to shut on the disc and also the hole. So I think they need to consider more about the flow that is, whether it is coming, what is passing through the holes or at other sides of the hole. And the third one is how does the size of the holes and on the disc affect sound? And I think for this is what they can also discuss about, because like just like what I have said in the previous, because they mainly focus about the frequency. So I think maybe the size of the holes can also affect the amount of the air. So I think this is what they can also try to consider in their experiments. And also, how does the holes settled on the disc affect the phenomenon? Because for the experiment, I think the distance between each hole are mostly the same. So how about if we change the distance between each holes, and would it have other influences, or what can we observe for the or what can we observe? So overall, I think for the reports, I think there are like two. Although they talk about many variables such as the numbers of the hole and also the speed of the rotating, but it's mainly focused on the frequency. I think maybe they can have more things to discuss. Maybe they will have more things to discuss.
Thank you.
Okay.
Discussing.
Okay. Can we go to the work? Can you draw the picture of the flow passing through the holes? Like what directions?
Can you turn to page 9? Page 9. So this is how the airflow passes through the hole, and how it is interrupted when the metal perforated disc is rotating. It interrupts the airflow.
No, I mean the angle.
The angle.
Yes.
Oh, I'm controlling the nozzle of the wind blower to be directly onto this part. So this is the nozzle of the air compressor. So the airflow should go in this direction.
Okay, but don't you think, because I have saw that in your experimental setup, like the direction of your flow is like from this direction, right?
Yeah.
But also you have like a brush or something like underneath.
That's a motor.
Yes, that's a motor. So do you think it will have the flow of the reflection level coming back and influence?
Oh, that's
affect
considered. Please turn to the next page. That's considered inside the noise reduction. Since when the wind is hitting on the metal perforated disc, it also has. If this happens, then it also happens in this situation when it is not rotating. So we try to reduce the other noises that comes from the wind hitting the disc.
What don't you think that if you change this direction to like maybe the flow is over here and the hole is from this direction?
And how can you spin the rotating disc?
No, because like you can control the
Like that is nozzle? Like
No.
the nozzle of the air blower gun.
No, I think because you use the nozzle, so that you cannot consider this the refraction of the air. But I think if you change it to this direction, maybe it
Then
will.
how can you spin your disc in this direction?
And but because why? Because the tool you use to create the flow is the metal, so that you cannot control. But I think
So
maybe it's better to try
the
it.
reviewer disagrees with this part, since I believe that we try to avoid most of the noises and unpredictable noises that might cause in every situation by reducing the noise and when the rotating disc is in a static state. So we try to reduce most of the noises of the wind hitting on the metal perforated disc.
Okay. Okay, let's talk about the disc of the rotating. Can you explain more about the disc that you use? Like, is material or is what is
It's
this?
just metal perforated disc so that we make sure that there's no like bumps on the surface. And do you mean the diameters of the holes or the
Yes.
radius? So the radius that we're controlling, we control that this is a nozzle of the air compressor given by the air blower gun. So it's 0.4 centimeters of its radius. Of its diameter. So we control the hose of the disc, which is also 0.4 centimeters, so that we can make sure. So that, and also in our theory, we assume that the airflow can perfectly come through the hose on the metal perforated disc.
Okay, so why don't you try using maybe a bigger hole?
Oh, because
or,
for example, if today we're using a too small size hole, when the radius of the nozzle is this big, it will cause a lot of energy dissipation, or also it might flow into other holes. So it will cause unexpected noises that we cannot predict. And today, if the nozzle is too small for the radius, and then in different situations, it might flow through the hole perfectly, which is not our theory wants.
yes, but don't you think that if you use 0.4 centimeters and the hole is also 0.4 centimeters, but will the flow it's way so it
Oh no,
won't perfectly passing
it only
through the
perfect.
hole?
We can only assume that it perfectly matches with the hole when we control this as the same diameter.
Yes, but for this situation, like every time when the flow passing through the hole, you cannot consider the amount of the flow passing through it.
What do you mean like passing?
Yeah, because of the rotation. So like for example, you have the rotation in this direction. So maybe it will also it will also affect the direction of the flow.
No, but if the diameter of the hole is too big, then in a lot of situations, for example, like the diameter is so big that it only has 2 holes on the disc, and when it's rotating, for example, the first second and the second second, it can also, in different situations, it can pass through the hole perfectly, but if it passes through the holes frequently, it will not cause the frequency in our experiment, which we said that the frequency equals to this.
Okay, thank you. And how about, do you think the shape of the hole on the disc will
So
influence?
it's the same reason why we control that it has the same diameter, to reduce most of the energy dissipations that might come from the wind is not blowing directly or completely through the hole.
Okay. How about because like for each hole, like did you consider it the same distance between each hole?
Oh, as long as the distance between each hole is larger than the 2r, like the diameter of the hole, then we can assume that the wind, like when the wind the nozzle is providing the airflow, it will not have it will not overlap with 2 holes. So as long as there is as long as the hole has distance more than 1 signal for the same hole, then we can change the value of P here, and it will not influence or cause deviation for the
Okay.
frequency.
So do you mean that for example there is a vessel over here, and do you mean that because of the disc is rotating, so maybe when it have the flow comes here, but it will also have influence another hole? Is this your meaning?
I mean like when the distance is too small, like less than, so for example this is r and this is r, but this is less than the radius of the hole. But there are some cases that the nozzle will have an overlaying area, like like blowing through two holes at the same time, which will not fit with our theory. So we cannot predict this unexpected situation.
Okay. How about like do you think that if you change the distance between the holes, like maybe what you said is that you need to like bigger than 2 radius.
Yes.
So how about like you change it to like make bigger to 3 radius and 4 radius? What will the result be?
Oh, if it's so is the distance between each hole different or the same?
The same.
Oh, then you're just increasing the number of the holes on the disc, and it will not affect. It will just, like, for example, it's 2, and the frequency will be 2 and 0, and then it's 4, and it will be.
Also, it means the frequency will. Also, do you mean it affect the frequency?
Oh yes, because it interrupts the airflow more frequently.
Okay. How about you think that if the distance between each pulse is different, what do you think that it will cause it?
You mean like, for example, this distance is different with this distance?
Yes.
Then in our theory we cannot assume that it travels, it has related to this, because I'm not able to predict the frequency of it to be interrupted.
So don't you think that it will like for the frequency like when every time when it speaks like don't you think that the frequency will be different?
Yes, it will be different than original, but I'm not able to predict how different length between each hole is different, and it will cause unexpected peaks.
Okay. Okay. How about how can you confirm that your pressure is measured?
How did I measure the air pressure?
Yes.
I only measured the wind speed from the air compressor.
Also, don't you like decrease any outer influence or other resistance or other things that will affect the?
The wind is directly from the air compressor to the nozzle, so we believe that we reduce most of the factors that might change the pressure.
Okay. Thank you.
Okay, time's up. Okay, the opponent summarize the discussion for the next minute.
For the discussion, like we mainly focus about the geometry of the holes on the disc, and the geometry of the holes on the disc, like we talk about like the size, the distance between each holes, and also the size of the holes. And I think these factors will affect the frequency of the flow that passing through the holes. And also we talk about many factors that maybe have some outer disturbance or other resistance that will affect the experience. What the reporter said is that they remove the result that have bigger differences from the many results. But I think maybe it's better to like change their experimental setup to decrease the.
Thank you. Time's up. Okay. Next we have the reviewer to ask question for the next 3 minutes. Reviewer.
So first, for reporter, what factors do you think will affect the experiment and how it will affect it?
So,
Just in short.
So as I mentioned, the angular velocity of the rotating disk and then the whole numbers on the atom-converted disk. So these 2 parts.
Okay, so you use a lot of formula. How did you get it? Did you just search it on the internet or you derived it yourself?
Oh, so this is easy to derive since the frequency equals to how the airflow is interrupted, how frequently it is interrupted. And we know that it is interrupted due to these factors, so that it's easy to derive this formula by ourselves.
And then, your PPT mentioned that carbon vortex rate.
Please turn to page 20.
Could you tell more, talk about it more?
Oh, so when it's in a specific Reynolds number, when the wind increases and causes the Reynolds number to reach the specific Reynolds number, we believe that Kármán vortex street actually happens inside our experiment. Which Kármán vortex street is the fluid traveling through an obstacle and causes the oscillating and generate a specific frequency of the vibrating. And which we found after calculation, we found out that the Kármán vortex street's specific frequency is about 700 to 900 hertz. And in our experiment, we also found out that the trend of intensity here does not fit with this slope here.
Okay, so for this chart, can you explain how the peak is? Why there is
The intensity or
yeah.
so from this part you can we are able to predict the relative intensity through this formula. We found out that it is proportional with n and this coefficient. And also we found out that this is our theory line with our data. However, there is still deviation, which we believe that might cause by the turbulence and assumption of the theory that might cause energy dissipation.
Okay, do you think the assistance between two poles affects the rules of the wind?
The distance between two holes, or
The distance.
Thank you, time's up. Okay, review overall, the preparation time 2 minutes. Okay, review will take the floor for 2 minutes.
Okay, I'm reviewer and okay. The problem statement is this is the problem statement and main focus in this experiment. So in air sound propagates through longitudinal waves. So okay, So I want to ask that, how did reporter measure the wind speed and will the background affect? Well, I think the opponent just asked the question, and how did the turbulence assumption and energy dissipation? And I just asked about the question that why there's peaks on the chart. Okay. Reporters are pros and cons. Pros that he has a clear chart to observe the differences between the original and noise. And there are full theory and formula. And according to what he said, they derive the formula themselves. I think that's very good. And they explain the formula and theory, experiment, and charts clearly. Okay, and well, some of the charts are drawn accurately. Well, in my view, there's a little not clear, and didn't tell how to solve various kinds of dictation. Well, yes. Didn't consider the size, like how pulse affect the experiments, okay. And didn't control the direction of the wind well and can predict the frequency. Okay. Opponents. Well, the opponents analyzed how the parameters affect the result clearly. And pros and cons. Consider the parameters of the background that might affect the wind speed. They also consider many factors like the shape and the size of the holes and other. Well, not only frequency. Well, cons. Well, the only cons is that their discussion usually focus on similar questions. Okay, so about the parameter. For a reporter, the size of the hole should be the same so the wind can pass through perfectly. Okay. And for opponents, the shape and the size of the hole will affect how the wind passes through the hole. So we agree with the opponent because the airflow will spread. It is important how the distance between two holes affects the route of the wind. So missing points. The only missing points for reviewer is that they didn't talk about how to solve the limitation like I just mentioned on the page before.
Time's up.
Okay.
Okay, reporter, make the final concluding remarks.
All juries follow competitors. This is a concluding remark from the reporter. First of all, for the opponent, we consider the background noise to reduce the deviation of sound frequency. And in this part, we use fast-forward transformation to minus the original intensity. We use the original intensity to minus the intensity of the noise to reduce most of the deviation caused by this part. And we use an air compressor in our setup to stabilize the speed of our airflow. And for the reviewer, we use a wind speed meter to measure for the wind speed. And this can enhance the reproducibility of our experiment. And the matter for this is just that it can reduce the deviation caused by material since there are no bumps on the surface. And we control the radius of the nozzle to be the same as the hose. So in our quantitative calculation, we can perfectly predict our experimental result. And the energy dissipation can be reduced by controlling the distance between the holes because there might be unexpected airflows that flows on the disk but not entering the holes on the disk. And by considering carbon vortex streak, we can explain some of the peaks that has intensity not following with the trend, which is about 700 to 900 hertz in our experiment. And for the reviewer, the nozzle radius is larger when the nozzle radius is larger than the hose, then it causes energy dissipation. And when the nozzle radius is smaller than the hose radius, then we cannot control the airflow. And the position of the nozzle is restricted directly on top of the hull, so that we can prevent the energy dissipation and prevent airflow influencing other holes. and the deviation are considered and explained in our report. For example, for your relative intensity part, we explain that it might be caused by the turbulence and assumption, which might cause unexpected energy dissipation inside the system. Thank you.
All right, time's up. Okay, thank you. Next, we will have a question from the jury. Any questions?
I have a question for the amplitude of the sound. According to the reporter's data, it seems that, according to the data in your chart, it seems that your fundamental one and all the overtones have a more or less very close, similar amplitude. Is that true?
Oh, because as long as we did not change the wind speed, since we mentioned that the wind speed's cube is proportional to the intensity. So as long as the wind speed is not changed, most of the intensity will not be changed. But the relative intensity will be changed when we increase the hold on the disc.
Alright. According to what I have seen from the YouTube videos, where people did the same experiment, usually they generated a very loud single frequency sound from the experiment. But according to your data, it seems you have a lot of more or less similar frequencies with the same amplitude.
Frequencies with the
I mean the loudness of all your overtones.
You mean the unit or the scale pairs or?
Well, I'm expecting you to have a higher amplitude for the
Oh.
equal n equal to 1, which is a fundamental frequency. But
The amplitude will not change as long as we did not change the wind speed.
right, okay. No problem, yeah, thank you.
Any questions? No? Okay, all right. Okay, I don't have any questions either. Okay, so we're gonna have a few minutes to make our break. Thank you. All set? Okay. Okay, now we have our break for the reporter. Eight, 7, 7, 8, 8. Okay, now we have the break for the opponent. 7, 5, 5, 5, 7. Okay, we will have the break for a review. 6, 5, 5, 5, 5. Thank you. We have 15 minutes recess. Thank you. Okay, have your team members, please.
Her name is Xu Ceng, Wang Yuhong, she's on.
All right, thank you. Welcome. Okay, next.
Good afternoon, I'm the captain of Team Excelsior, and I'm from Concordia Middle School. Excelsior is just a traditional name from our school, so we use the same name as this last year. So these are my teammates: 陈以泰、庄玉飞、李坤宪、蓝少成, and I'm Huiying Ray.
All right, welcome. Okay, and the third team.
Hi everyone, we are Emily and we are from Kaohsiung Girls High School, and the reason why our name is We Are Family is because at first I thought it would be only my personal accounts, and I was at a convenience store like Family Mart and I heard it play and yeah, just me, yeah. And so I just typed We Are Family and it turns out we are group name and we show up there, so it's quite embarrassing. Anyway, this is 张日慈、陈奕轩、Wen Ting, Guo Shanren, and I'm Li Xingren, and it's really nice to meet all you guys.
Okay, welcome. Okay, thank you. So, right now we're gonna have the opponent challenge the reporter for a problem. Okay, you can start. You can start. That's okay.
One.
You can start anytime. You can start now or inside 1 minute. It's alright. It's your choice.
She said
One.
Oh,
Yes.
sorry. I'm sorry. I
Yes, I say-
misunderstood you.
One.
Okay, let's try problem number 1.
Accept.
Okay, that's it.
Yes. Yeah, that's your right.
Yes, try for finger.
Yeah, right with fingers. And that's that. Alright, so please all the speakers come to write down your name on the board. Okay, 5 minutes to prepare for the reporter. Time's up. Okay, reporter, you can present the report.
Hello, judges and competitors. This is Hong Yihong from Team Robotics, and today I will be reporting problem number 1, fractal fingers. And this is the problem statement. The effect of fractal fingering can be observed if the droplet of an ink and alcohol mixture is deposited onto diluted acrylic pen. How are the geometry and dynamics of the fingers influenced by relevant parameters? And today our main focus will be putting on how does the concentration of the alcohol of the fluid influences the spreading, and also what can causes fractal fingers. And this is the outline today. First, for the observation, we will mainly focus on observe the diameter of the spreading and also the extent and color of the fingers. And first, for the observation, because for the experiment, we try to change the concentration of the ink and alcohol fluid. So for these two videos, the ink and alcohol fluid is 1:1 and 1:2. And from this video, you can observe that when the ink and alcohol mixture is 1:1, the spreading will be slower, but the color of the spreading will be darker. While for this video, the ink and alcohol is 1:2. So you can observe that the spreading will be faster, but the color of the spreading will be lighter. Okay, now let's talk about the theory. And the first theory is Marigoni effect. And imagine two fluids with different surface tension mixed together. The fluid with a higher surface tension will have strongly pulled another fluid with a lower surface tension. And just like the video. In this video, there are two kinds of fluid. One is a water fluid and another is a soapy condition, that is a soapy water. And so we put some pepper onto the water to observe the phenomenon more significant. So when we drop a droplet of soapy water onto the water, you can observe that the pepper will quickly spread to the outer. And that means because the surface tension of the water is higher, so that it will pour the soapy water, because the surface tension of the soapy water is lower. And for this picture, this is the picture of our experiment. And for the diluted acrylic pens, the surface tension is higher, so it will pour the ink and alcohol mixture, because the ink and alcohol mixture has a lower surface tension. And another theory is Safeman-Taylor instability. And imagine when two fluids with different viscosity mixed together, the fluid with a lower viscosity will create a disturbance that can decrease the resistance. So the fluid will follow the path with a lower resistance, just like this our experimental picture. The border of the ink and alcohol mixture, it can create a small disruption, and that can decrease the resistance of the fluid, so that it will cover another fluid with a higher viscosity. And among the two theories that we have already taught, the differences preparation of ink and isopropyl alcohol can influence the spreading. And also the larger difference between the viscosity of the ink and alcohol mixture and the diluted acrylic paint, the more significant the fingers will be. And this is our experiment setup. And for this experiment, we need to prepare two kinds of fluid. One is the ink and alcohol mixture, and another is a diluted acrylic paint. And for these two fluids, we need to change the concentration of the fluid to see its results. And for the base, we choose the material we choose is wooden base, and the height that we drop the ink is 5 centimeters. And on that chart, that is a relationship between the viscosity of isopropyl alcohol and the ethanol. You can observe that the viscosity of the ethanol and water is more similar, but the viscosity of the isopropyl alcohol and the water the differences is bigger. So the finger will be more significant if we use isopropyl alcohol. And these are our variables. For the independent variables, that we change the proportion of the ink and alcohol mixture and also the paint and ink. And for dependent variables, we need to observe the diameter of the spreading and also the visibility of whole fingers. And this is our experiment. And we tried 4 kinds of different ratio of the ink and isopropyl alcohol, which are 1:1, 1:2, and 1:3, and 1:4. And you can observe that when the isopropyl alcohol is more, the spreading will be more bigger, because the diameter is 3.5 and 4.2 and 4.5 body. So we think that is because when the isopropyl alcohol, the amount of isopropyl alcohol is more, it will have a bigger viscosity, so that it can the ink and alcohol mixture will cover the diluted paint. And also to observe the color, you can observe that when the isopropyl alcohol is more, the color will be lighter, and that is what we can see in this equation. And if you're wondering how we measure the diameter, you can observe that there are actually an inner circle and an outer circle. For the inner circle, it's more circular, so that where we measure is the inner circle. And so when we control the ink and alcohol mixture as 1:2, but change the water and paint mixture as 1:2 and 1:3, and this is what we can observe. And when the water and paint is 1:3, the diameter will become 4.1 centimeters. And the water and paint is 1:2, the diameter is 3.7 centimeters. So when the amount of paint is more, the diameter will be bigger. And what can causes the fractal fingers? This is a bigger version of the fractal finger that we observed in our experiment. And so in the previous experiment, why we change the proportion of the fluid, that is because it can influence the viscosity of both of the fluid. And if the differences between the viscosity of two fluids is bigger, and the fractal fingers will be more significant. And for a conclusion, after the experiment, we found out that the more amount of isopropyl alcohol we added, we can observe a larger circle. And that is because the isopropyl alcohol can affect the viscosity of the fluid. So when we have more isopropyl alcohol, the viscosity of the diluted acrylic paint will be higher. So it will pour the ink and alcohol mixture. And also, when the more amount of the isopropyl alcohol we added, the less amount of zinc would be expanded. According to the experiments previous, we can observe that if the amount of isopropyl alcohol is more, the color will be lighter, and that is because each time when we drop that onto the diluted acrylic paints, the amount of the ink and alcohol mixture is the same. But if the diameter is bigger, it will have a bigger area. So that means that the spreading will be bigger. So that means that each part will have less ink. So the color will be lighter. And also, if the proportion of isopropyl alcohol is larger, the fractal fingers will be more significant. Just like the experiments in the front, and if we have the more isopropyl alcohol, actually in the border, the fractal fingers will be more significant. The shape will be more significant. This is the experiment we can do in the future. And to make our experiments more complete, I think the most important thing is to quantify the fractal fingers. Because from the experiments above, like we just use our eyes to observe the fractal fingers. So I think next time when we do these experiments, we can try to count the amount of the fingers, and also to measure the speed of the spreading, and also the length of the fractal fingers. Although maybe we need to try to find out the relationship between these three kinds of different factors. Also, another thing that we can do is to measure the viscosity of each fluid. And what we can do is to prepare a cup of fluid and use a small subject to drop it and let it sink to the bottom. So we can try to measure the VT graph of this condition, and then try to find out its viscosity of the fluid. Also, according to the theory we have talked about, we talk about two theories. But one is about the viscosity and another is about the surface tension. But we think that it will both influence the result of the fractal fingers. But we try to find out the relationship between these two theories and try to know that which theory will influence this, will have a bigger impact on this experiment. Thank you.
Okay. All right. Then, I'm sorry. The question from the opponent to the reporter for 2 minutes.
Okay. I want to ask, did you control the temperature of the experiment?
It's because we do all the experiment in the same day, the same time, so the differences between the temperature won't be so big. It will be similar. The temperature will be similar.
Okay, and you mentioned the length of fingers and the speed is spread in the future experiment, so you didn't measure it, right? Oh, sorry, you didn't measure it. Yes.
For this time, we just observe the geometry. Maybe next time we can try to quantify the fingers
Okay.
to make our experiment more complete.
And how about the area of spread?
Area. Oh, because in the experiment we actually measure the diameters of the spreading. So that so if the diameter is bigger, then actually it will have a bigger area. Yes.
Okay, but in the same diameter, some shades are rounder, but some shades are irregular.
That is why we choose to measure the inner circle, because inner circle is more circular. Because we think that there will have an outer circle and inner circle, because when the fluid first spreaded, when the viscosity of two fluids when it becomes more similar, it will actually come to the inside again. So we think that the inner circle is the circle that.
Okay, the surface tension is the main reason influence the experiment. Do you agree?
I think that the viscosity and the surface tension will both influence this experiment.
But viscosity influence the surface tension, so the surface tension is the main reason influence the experiment?
There is a formula as V equals to delta gamma divided by mu, and V is the flow of
Thank
the.
you. Time's up.
Yes.
Okay, opponent will have 3 minutes to prepare for your next step. Okay, opponent takes the floor. Maximum 4 minutes.
Opponent from the Wear family team. And it's a public statement. The effects of fractal fingers can be observed. The droplet of an implacable mixture is disposed onto the applicant. How the geometry and dynamics of the fingers influenced by relevant parameters. We may focus on the concentration of fluids and the spread area and length of the wing. Yeah. And the pros of a reporter, they have full of theories and future experiments. But future experiments, on the other hand, means they didn't do very well on this experiment. But as cons, didn't talk about the accuracy of the concentration. They only control the alcohol and ink, but they didn't control the water or other things with acrylic pens. And they didn't consider the outer circle of the finger. Yes, and they need further research to apply their theory. And it's our discussion of the theory. This variable may influence the experiment we see, like fluid viscosity and fluid concentration and surface tension between two kinds of fluids. And as we said, the fluid viscosity, the fluid concentration influence the fluid viscosity, and the fluid viscosity influence the surface tension between two kinds of fluids, and also gravity influence some experiments. So
I think the surface tension between the two kinds of fluids is the main variable of this experiment. And the experiment, I think something we have to measure, like the speed ink spread on the upper hand, like yes, they also mentioned, and the length of fingers, because their fingers are not the same, so I think we can measure the maximum of the fingers, and also area of spread is fine to mention, and the shape looks random and irregular. Because of this shape, the diameter may not accurate, because if the shape is round and the shape is irregular, the diameter may be same, but the area may different. So yes. And there are some control variables, like the height it drops, and the temperature, because the evaporation rate of alcohol may affect the experiment, and is the surface of the upper hand flat? Because it's not flat, the fluid will go to lower. Yes, and the finger competence I will draw later. Yes. So discussion. They only control alcohol and didn't control the concentration of the operating water, and they use wooden board for base. Does it absorb the ink or water, and the concentration may change? And what's the method? Then and observe the motion of the finger. Thank you.
Okay, so we will have the rest of the time for the discussion.
I want to talk about the finger comprehension. Like this is a circle and this is a finger. If the fingers look like this, or this is a finger and there is no. So
Because that when we try to mix the mixture of the diluted acrylic pen and also the ink and alcohol mixture, that we try to wet, so we mix it very well. So the viscosity of the diluted pens will be the same, and also the viscosity of the ink and alcohol mixture will be the same. So for each direction, they will have the same viscosity. So that for the fingers, that should be mostly similar.
please back to page 4. This. This is a shape, but the diameter is this or this. They are not. It's not round, so we can know the.
Where we measure is that you can observe there is a circle. It's nearly a circle. So there is what we measure the diameter.
Okay. You say the circle in this, right? But some shape look like this.
Oh.
And some shape look like this.
Okay. That is because what you have mentioned is whether the diluted acrylic pen is flat. But we try to make it flat, but it will still have some place that is higher, but some place is lower. So for the picture that is like this, that means that it will follow area that is have a lower diluted acrylic pen. So just like what I have mentioned, where I measure is the inner circle, so it will be more circular. So that's what I measure.
And don't you try to control it flatter?
Yeah, we try to, but because it's
how is it?
man-made.
How is it?
This is a base,
Yes.
and we put it on. We put the acrylic pen on it, and we try to use a stick or something to make it to go through it. So like we try to make it flat, but it will still have some small areas.
But how about this is the base and drop it on it and you will spread flatter
Drop it on.
and have no bubbles. if you make it flat, it may touch the surface and some bubble of it, and it will influence the flat.
No, there are no. For the drop that it is the ink and alcohol mixture, so we use it to drop it on the surface of the diluted acrylic paint. So for the bubbles, because that we wipe it, so that the amount of the bubble will be less.
Okay. And you use, as I mentioned, you use the base is wooden, right?
Yes.
But the wooden may absorb some water or ink, and the ratio of fluid change.
Okay. Why we use the wooden base, that is because we consider the fraction of the material of the base. Because actually we try 3 types of different material, which is the glass and wooden base and also the paper. But for the friction of the wooden base, we think that is more suitable because if the let me show you.
Yeah.
This is the shear force that can create a spread. And here is a friction over this. So if the friction is too small, actually it will spread too quick, and so the circle, so the geometry won't be will be more irregular. So like we think the wooden base, the friction of the wooden base is more suitable. And what you have mentioned is that wooden base can absorb the water. Because for each experiment, these 4 experiments, that we all use wooden base. And also, what you have mentioned in there, you said that we didn't say the paint and water's ratio. Actually, that it is 1 to 1. So the amount of the water will be same. Also, even though the wooden base can absorb the water, so it will nearly absorb the same amount of water.
Are you sure? So because maybe the wooden base absorb, yes, it's one to one now, but it absorb one and so two and the ratio change.
No, but for these 4 experiments, the ratio is 1 to 1. So maybe after it absorbs, the ratio of the 4 experiments will be similar. I don't mean that it will be the same at first and I don't think this.
Okay, why you choose the ratios 1 and 1 to 1 to have some spatial reasons?
Actually, we use this 1 to 1, 1 to 2, 1 to 2, 1 to 3, and how we measure is that we use the weights of the ink and the carbon alcohol. We use the weight to measure it. So we use 1 to 1, 1 to 2, 1 to 3 is just to make sure that the proportion and the concentration of the fluid is different.
Okay, and as I mentioned, you only control the ratio of the alcohol, and how about the water and the output?
Okay, for these 4 pictures, the water and the acrylic paint is 1 to 1, just like what I have mentioned. But for the next page, actually we control the ink and alcohol ratio as 1 to 2 because the result will be more significant. But so the water and paint in this experiment is 1 to 2 and 1 to 3. So the spreading will be different. The diameter will be different.
Okay. And do you think the evaporation rate will influence the experiment a lot? Yes, the alcohol.
Do you mean that the water will evaporate or?
Yeah, maybe in the yes. When we are doing the experiment, the ink and alcohol may evaporation.
Yes, but this experiment is doing in a very short time. So the evaluation of the alcohol won't be so much. So I think this field is what we can ignore.
Okay. Don't you think the outside area is important?
What do you mean the outside?
Yeah. Well, I'll just say. Let me say this is let's say only the circle.
What I have mentioned is that we think that it's because when it spread out, the viscosity of the in and alcohol mixture and the acrylic diluted acrylic gas will be more similar. So when it becomes more similar, it will actually come inside again. So this circle will be more significant. That will be more circular. So it's easier for us to imagine.
But outside circle is also a phenomenon. We can find out. Why you ignore
Yes,
it?
but you have asked that why is this like the border is like this, and I say that is because whether the acrylic test is flat, but we try to make it flat, but although it will still have some errors. So if you observe the outer circle, that the circle will be more irregular, so it's difficult for us to measure.
But irregular is also important to find out. So
And I think that it is irregular because that the base, the acrylic paint on the base wasn't very flat.
other facts. So you have to make it.
Yes, we tried, but human made.
Okay, so irregular is man-made, right? Oh, sorry, it's man-made. Okay.
Yes.
Okay. So just say you try glass and paper, right?
And also wooden with yes.
Okay, so don't you think use glass is better?
No, what I
Okay,
have
thank you, time's up.
Thank you.
Okay, the opponent will summarize the discussion for 1 minute.
Okay, and we talk. Sorry, and we talk about the base, wooden or glass, and the area of the circle, and the diameter and areas, the relationship diameter and areas, and also we talk about the evaporation rate of the alcohol maybe will change the experiments, and why choose these ratios to do the experiment based on, and it's the acrylic paint flags. We talk about these varieties of the experiments.
That's it, thank you.
And
That's it.
the outer surface is.
Okay, Leo will ask question for 3 minutes.
Okay, so first, both of you agree that Marangoni flow is the main reason why the alcohol mixture spreads, am I correct?
I said that both the Marangoni effect and the sedimentary instability will both affect, but which one will affect bigger, that is what we can.
So do you agree with that?
Can you say it?
Marangoni flow is the main reason why the mixture spreads.
Yes.
Okay, so what is the main reason that causes the Marangoni flow to decline? Or do you think that the Marangoni flow will not decline?
What do you think?
Never mind. For the reporter, the finger motion is randomly formed but not symmetrically formed, am I correct?
No, that is due to the whether the acrylic paint and also the ink and melted.
So you
paint
think,
is well mixed.
so you think that the fingers can be evenly formed at the same diameter?
No. If it is more the border is like more bigger, the zigzag is more bigger. That means that we can observe the frontal fingers more significant.
But it seems to be randomly. Like the finger motion is randomly inside your experiment. And can you explain?
Randomly, what?
Like you cannot predict the motion of the fingers. So they are randomly formed but not symmetrical, which means that the fingers are not even spreadingly.
Yes. You can figure out that from the inner circle, it is more significant that it will have a small impact. So that is actually very crowded. So
do you think that the random motion of the finger is because the surfactant is unevenly mixed, or are there other reasons?
I think, although I have mentioned that we try to mix the ink and alcohol mixture and also the diluted acrylic paint, we try to mix it well, but maybe there has some small errors, so that will then
Okay, thank you. So why will the spreading motion stop?
When the viscosity of the diluted acrylic paint and also the ink and alcohol mixture is become more similar.
So it reaches to a balance. The Marconi flow spreading out and the viscosity reaches a balance. Am I correct?
Yes, it's almost the same.
So do you agree with that?
Let's say again.
Okay, never mind. So for the reporter, how did you measure the radius or characteristics of the finger?
We just from the inner circle, we just use a ruler to measure. So
How about the fingers?
fingers, that is just what we observe.
So are you able to
Can go to
take
like-
average numbers of the radius of the finger?
So that I have extended in the future experiment is that we can try to quantify the fractal fingers.
Okay, thank you.
All right, thank you, time's up. Okay, we'll have 2 minutes to review, to prepare for the next topic. Review takes the floor for 4 minutes.
Honorable jury's fellow competitors, this is a reviewer from Team Excel here, reviewing problem number 1, fractal fingers. Problem statement. The effect of fractal fingers can be observed if a droplet of an ink alcohol mixture is deposited onto diluted acrylic paint. How are the geometry and dynamics of the fingers influenced by relevant parameters? Here your problem statement, I believe that we should focus on the formation of fingers and how the geometry and dynamics of the fingers influenced by relevant parameters. This is a review of the report. And he conducted experiment parameters including the ratio of ink and the alcohol mixture, and the ratio of water and paint. And his theory include the Marconi flow and step-and-tailor instability. And for the data analysis part, he talked about the radius of the droplet and the size of the droplet. These are the pros and cons that I think the reporter had. First of all, he had a clear observation video about the spreading of the mixture, and he had a phenomenological explanation about the Marconi flow. However, he didn't have a quantified experimental explanation, since he didn't compare the experiment with the theory and don't have the deviation. Didn't explain any error analysis for this part. And he used a wooden base to conduct the experiment, which in this part the reviewer will suggest the reporter for using acrylic base or petri dish to conduct his experiment to reduce deviation. And he did not define the concentration of the liquid well, and didn't focus on the geometric pattern of the finger. And these are pros and cons for the opponent. First of all, she noticed that the lack of definition about the concentration of the reporter, and she did not discuss on the characteristics of the finger. For example, the shape of the finger, and she gave own suggestions to the reporter. However, she did not discuss too much about Maragoni flow, which the reviewer believes might be the main reason that causes the spreading motion. And she hardly discussed on experiment result and over-discussed on the material of the setup. So for the first key discussion, they discussed about what is the main reason that causes the phenomenon to happen. And the reporter answered Maragoni flow and Steffen-Taylor instability spreads it out. And the reviewer partially agrees with the reporter. I believe that it's a concentration difference of the alcohol mixture that causes the tension gradient, surface tension gradient in the system. And the surface tension gradient causes the Maragoni flow to happen, but spreads the mixture out. At the same time, the rim tries to remain its minimum surface energy, which randomly forms a finger. And for the next discussion about concentration of the alcohol, the reporter said the experiment is done in a short time, so it won't affect. In this part, I disagree with the reporter. I believe that the evaporation rate causes the concentration difference, which causes the surface tension difference, and causes the Maragoni flow to happen. And I asked the question, why will the spreading motion eventually stop? And the reporter answered, viscosity balance with the Maragoni flow. I agree with the reporter, since when Maragoni flow spreads out, the alcohol mixture causes the center part of the mixture has higher concentration, while the outer layer has a smaller one. After it reaches to a balance, it eventually stops. These are the points for the previous discussion. First, the formation of the finger. Since the problem statement has asked for the investigation of the dynamics and also the geometry of the finger. However, in the previous discussion, they did not discuss too much about the geometrical characteristics. For example, the amount of the finger and the radius of this finger. And I also believe that the surfactant should be discussed, which might cause why the finger would not shrink into small droplets. And they did not discuss about the driving force of viscosity and surface tension, and will initial disturbance such as dropping height and capillary wave affect or cause deviation in his experiment.
Thank you.
Thank you.
Okay, we will have 2 minutes for the reporter who may be on concluding remarks.
Okay, now I will talk about the concluding remarks of the presentation. And so from the opponent, they say that for the temperature and gravity, because we think that the experiments are done at the same time, so which the temperature and gravity is the same. And the temperature we did the experiment is approximately at 20 degrees, so the viscosity of the isopropyl alcohol and the ethanol and water is based on previous studies. So which is offers the value in 20 degrees. And for both opponents and the reviewer, they think that the evaluation will affect the experiment, but we think that because we done it at a short time, so maybe what they said is correct, but I think the influence will be very small. And also for the accurate concentration, we did 2 experiments. One is changing the ratio between ink and alcohol, and the other is changing the ratio between water and paint. And how we measure the concentration is that we use the weight. And for bubbles, that because when we wipe on the base, that we just didn't have this problem. But for the base decision, consider the friction. Wooden base is the more suitable to pour the fluid gently to create a more regular spreading shape. So we also try glass and express too fast in an irregular shape. And for evaporation, the experiment done in a short time, so like it didn't affect very much, just like what I have mentioned previously. And from the reviewer, can fingers be evenly spread, and there will be deviation in the spreading, but there is still predictable in some ways, whether it's significant or not. And the opponent disagreed with the reporter in the capability of making prediction of the figures. And when the
Thank you, time's up. Okay. Next, we'll have the question from the jury.
To the reviewer, you ask the reporter about the randomness of the finger growth.
Sorry, can you rephrase?
You ask the reporter about the randomness of the finger growth.
Yes.
Do you have some idea?
So I believe it's because the surfactant or the ink alcohol mixture is unevenly mixed, so which causes the spreading motion. After it spreads, because it is unevenly mixed, so it will have different evaporation rate and cause different concentration. And it tries to, and after Marconi flow spreads the mixture out, it tries to remain its minimum surface energy, so it causes the finger to be randomly formed.
Do you think if you have better equipment, can you make this process deterministic?
I think it's still too idealized, but it will cause it to be formed more evenly, but it's still hard to make all the fingers to spread at the same radius.
Okay, the same question to the opponent.
If we have the better equipment, I think this experiment must be some random, but we can control it to the smallest.
Okay.
just like what I said in the previous slide, when I think the method is when we mix the mixture. So maybe when we are mixing the mixture, it is not very even. So maybe next time we have a better tool or better equipment that can have a better mixture, that can make a better mixture. Maybe it will become more even.
Yeah. We want to talk about some random. It must be random, but we can collect more data and we collect it and to know the average. And I think it's the best way to control the random.
Okay. So one of the missing point reviewer mentioned is the geometrical characteristic of the fingers, right? So I'll ask three of you, starting from the reporter, and opponent, and reviewer. So what type of, if you conduct the experiment again, what type of geometrical characteristic you are going to look at? For the fingers.
For the finger that I have mentioned in the future experiment is that the length of the finger and also the amount of the finger. So, but I think, but because the finger is so small, so I think if we have a better equipment, maybe we can observe this more precisely.
Opponent.
Yes, we think it's a future experiment, and yes, we also do the experiment too, right? Yes, and
Yes, you can mention, you can mention your experiment.
okay, and we measure the areas of the spread and the speed of the spread and we observe the shape. And I think it's important in the experiment, but they didn't mention it. Yes.
So I believe that they can analyze the average of the length of the finger for the temporal evolution, or the spreading speed of the fingers, or how many fingers are formed, or how many times it spreads. These are the dynamics and also geometry that I think can be discussed.
All right. Thank you. Okay. Okay, first we're gonna have the grades for the report. 6, 5, 4, 5, 6. Okay. name the grade for the opponent. 77668. 77668. There's a delay between the keyboard. Alright. Okay. Alright, and we'll have the grade for the reviewer. 87888. This is a shit, it's grade 8, right?
8.
8. Alright. Okay. Thank you very much for today's